Hey everyone, and welcome to this explainer. I am super thrilled to have you here today because, well, we're looking at a pretty fascinating technical mystery. We're going to explore a system called EasyOS Excalibur, and specifically, we're going to look at exactly why its benchmark numbers might completely deceive you. Honestly, if you've ever judged a piece of tech based entirely on a synthetic speed test, you're absolutely going to want to pay close attention to this one.
Okay, let's dive right into this. The core thesis of our entire explainer is just incredibly simple. Users experience systems, not benchmarks. It's such a straightforward statement, right? But man, it carries a ton of weight. Think about it. When we sit down at our computers, we aren't feeling a spreadsheet of read and write speeds. We feel the human experience of the machine. We feel that real-world fluidity. We notice how fast a window opens or how smooth a web page scrolls. And as we'll see today, that human experience matters so much more than whatever synthetic numbers a testing program spits out at us.
Section 1. The First Impression. The 30-Second Trap.
I want you to put yourself in the shoes of a newcomer for a second. Imagine booting up EasyOS Excalibur for the very first time. The user journey here often follows a really predictable, four-step path. First, you boot the system. Then, naturally wanting to see what it can do, you immediately run a disk benchmark. Step 3, the numbers come back, and honestly, they look pretty unimpressive compared to a conventional, SSD-focused Linux setup. And finally, Step 4, you just assume the system is inherently slow. It all happens in the first few minutes, sometimes literally the first 30 seconds. But here's the kicker. This quick sequence of events leads to a fundamentally wrong conclusion. Why? Simply because EasyOS isn't even playing the same game as standard distributions.
Section 2. The Benchmark Illusion and Why Metrics Fail Here. Now, what's really interesting about this is,
when we look at classic evaluation metrics, things like disk speed, application launch time, boot speed, storage throughput, and overall SSD performance, we have to realize they aren't inherently bad. In fact, they make perfect sense for traditional Linux distributions. Standard systems are heavily dependent on continuous disk access. They're constantly reading and writing to the drive just to function. So testing the drive gives you a really accurate picture of how that system will perform. But, we have to remember, we aren't talking about a standard system today.
There is a really sharp, fascinating contrast in engineering philosophies here. Traditional Linux, as we just established, relies on continuous SSD access that essentially acts as an anchor for its speed. But EasyOS Excalibur, it operates largely in RAM with minimal SSD dependency. By relying on random access memory instead of the physical storage drive for its moment-to-moment operations, EasyOS is completely bypassing the very hardware bottleneck that traditional benchmarks are designed to measure in the first place. No wonder the tests get confused.
Section 3. The Architecture Reveal. A Hidden Superpower.
Real-world fluidity. That right there is quite possibly EasyOS's most misunderstood strength. You see, this incredible advantage only actually appears during physical usage. You literally have to be sitting there, moving the mouse, browsing the web, opening your files to feel it. Because it fundamentally sidesteps traditional storage mechanics, this fluidity is entirely invisible to synthetic tests.
So, let's break down the technical wizardry making this happen. Longtime EasyOS users understand these architectural concepts intimately. The system runs largely in RAM, which, is exponentially faster than even the best SSDs on the market. It uses a layered file system behavior. Temporary writes, caches, containers, and overlay systems, they all stack on top of each other dynamically in memory. What this means is that your workflow depends very little on the actual SSD. Actually, scratch that. In some cases, it's almost entirely independent from it. These concepts change the equation completely. When your workflow is happening inside lightning-fast RAM rather than constantly waiting on a storage drive, running a disk benchmark is honestly like measuring the top speed of an airplane by testing how fast its landing gear can roll on the runway. It just tells you the completely wrong part of the story.
Section 4. Measuring what matters. Perception versus reality.
And this brilliantly illustrates the real question. When you stop staring at the benchmark scores, how does the system actually feel? Well, the real-world experience is phenomenal. The browser feels incredibly snappy. Applications open with genuine agility. The desktop remains highly responsive even when it's under load. Because operations are backed by RAM, everything just feels immediate. And as an awesome bonus, you get reduced SSD writes, which literally prolongs the life of your physical hardware. The entire workflow just feels unbelievably lightweight. But we're dealing with a lightweight feeling that is notoriously difficult to express with a single, simple benchmark number.
It's a real shame because a technically brilliant operating system can be tragically misunderstood and even abandoned by new users simply because it's being judged by the completely wrong metric. If that first 30-second impression is based on a flawed premise, adoption absolutely suffers.
So, this demands a complete paradigm shift. We desperately need new evaluation criteria for unique systems like this. Instead of just staring at disk speeds, we should be evaluating real responsiveness. We should measure browser fluidity, RAM efficiency, and the actual reduction of disk writes. We should be looking at the true speed of our workflow and how smooth the system remains during long, demanding sessions. This is how you properly measure a system that is designed around memory rather than storage.
So the whole thing really comes down to this one crucial question. Are we measuring the right things? Because when we let outdated synthetic numbers dictate our tech choices, we risk missing out on true innovation like EasyOS Excalibur. I want to invite all of you, whether you're a newcomer to Linux or a long-time seasoned veteran, to totally rethink your tech evaluation habits. Don't just test your systems, actually experience them. Thank you so much for joining me for this explainer, and I really hope this sparks some great curiosity the next time you boot up a new OS. Catch you next time.